Hi everyone, welcome back, and in this video we're going to be talking about dimensional analysis. So in physics, a lot of the time what we'll do is we will take some data and graph the data and try to come up with some sort of a straight line relationship. And we'll talk more about this in a later video, but for the most part we're going to be looking at least this year, kind of linear functions. We're going to try to linearize data. But when we do that, we will come up with some type of equation. And we want to know whether or not this equation is correct. And so one way to do this is through dimensional analysis. So dimensional analysis is similar to what we would call unit analysis. It's a little bit different though. There's three basic dimensions or units that kind of go into everything in physics. So the first would be length. So length or distance. And these all have the same base unit. We put it in brackets with an m, but that stands for meters. Now of course you can also have centimeters and kilometers and millimeters and so on. But for the most part, we stick with the base units, and meters, or m in brackets, is one of our base units. The second one is for mass, and that is the kilogram. And of course, you can have grams and milligrams, etc. But kilogram is the basic one. And then finally, we can also have time. And time is seconds, and that's with an S. Okay? So these are the three so-called base units that everything in physics is based off of. For example, if we wanted to describe velocity or speed, that's simply distance divided by time. And so that would be units of meters divided by units of seconds, or units of distance rather, divided by units of time. So meters over seconds. So that would be meters per second. And this is a so-called derived unit. Why is it derived? Well, because it came from two others. It came from meters and seconds. Okay, so how does this work in the context of an equation? Well, let's say we have an equation, v final equals v initial plus acceleration divided by time. And acceleration, by the way, is basically a change in speed divided by a change in time. Don't worry about that. We'll talk more about the details later. But basically what we're doing is taking meters per second, whoops, let's make that units, and we're dividing by seconds. So you probably know this, that acceleration already has units of meters per second squared. Okay, so now we go to our equation and we say, okay, what are the units of speed or velocity? Well, it's meters per second. What about the units of this velocity on the other side? Well, that's also meters per second. And what we want is we want to get the same units on each side. That's going to tell us that we are dimensionally correct. Same units on each side. So far so good. But now we do acceleration divided by time. Well, acceleration is meters per second squared, and time is seconds, so that's really meters over seconds cubed. And so what we see here is that we have meters per second equals meters per second plus meters per second cubed. Now if it wasn't for that last term, we'd be good, but as we can see, these terms are not all the same because these two don't add together. So therefore, this equation would not be dimensionally correct. And what that tells us is that this equation, VF equals VI plus A over T, can't possibly be right. Now on the other hand, if we write it like this, VF equals VI plus A times T, we see that that could be correct because we have meters per second squared times seconds, and that does give us the correct units of meters per second. Okay? Now if we have meters per second on one side plus another meters per second on the other side, that's okay. All we need is for these things to all be the same. We wouldn't write that as 2 meters per second. It doesn't really work like algebra. It's more like looking at the units. And we also don't know whether or not there's a 2 in front of this or 4/5. This method of dimensional analysis doesn't really tell us anything about the coefficients. We're going to need to do something else to determine that later. So that wraps up this discussion of dimensional analysis, and you'll have some practice on this on your homework and throughout all of the course.